Hello to you all matriculants and welcome to your favorite subject, which is mathematics on Learn Extra. DSTV channel 319 with me, AB, and Tamerlane.
Hi.
Tamerlane, how are you?
I'm well. How are you?
I'm good. It's good to see you.
It's great. It's great to see everyone.
I'm tempted to say Happy New Year because
Well,
I'm seeing you for the first time this year.
So Happy New Year to everybody from me.
Welcome back. How
Thank
have you
so
been?
much. Very well, thanks. How are you guys?
Awesome. I hope you are studying. What are we doing today?
Today we are doing some finance. So a really practical section, something that you can really see where it fits in the world out there. So a really nice section to work through.
That's nice. I must say it comes in very handy after the budget speech.
Absolutely,
we need to understand our finances.
Especially for the matrics who are planning to buy cars and those sort of things.
And the matric dance farewells.
And the matric dance and all those things that you have to start saving money for. So there we go.
So there's a lot to think about. I like that.
For sure.
Otherwise, Monsitors, last week we were running our competition for the last time, our Vodacom competition, whereby you stood a chance of winning an airtime voucher worth 110 Rand. Now we have the winners from our three shows which we had last week on the 6th. On Thursday, we had a winner from the geography show and accounting show and maths literacy show. And these are the winners that we had from last week. Romario, congratulations to you. You've won yourself an airtime voucher worth 110, proudly sponsored by Vodacom. And Astrid Bucas, congratulations to you too. And the last winner is Lerato Mathangu. The winners will be posted on Facebook, and congratulations to you, proudly sponsored by Vodacom. So you have airtime worth 110 to call all your friends and your loved ones. But it doesn't end there. That was another competition. We have another competition that is running now on facebook.com/LearnExtra. It is our Walk Together campaign, whereby you stand a chance of winning an awesome pair of tummy takers like these ones. Look at them, Tamerlane. Look at them.
Those are nice
Look
and
at
white.
this.
Hey,
Look at
wow.
Look
Don't
at
go out in
this.
the rain in
They've got
those.
swag, I tell you. They've got swag, trust me.
Wow.
So you can stand a chance of winning these awesome tummy takers. All you need to do is to caption the picture that is posted on our Facebook page, and then get your friends to like your caption, and then the caption with the most likes gets to win a pair of tummy takers of their choice with your favorite color, of course. So we have our winners from last week's show. I'll be telling you as the show goes on. But otherwise, congratulations to everybody. You still have a chance. The winners will be announced this Friday at 1 p.m. But for now, let's get on with our lesson.
Right, let's get on with it. Well, guys, as I mentioned, we are going to be having a look at finance today, and a really, really important section, but one that I'm sure you're going to really enjoy because you can see the practical elements of it. Right, so let's have a quick look at what our lesson description, what we're going to be working through today. All right? A lot of the finance that we will be working through today, a lot of it you will have already seen in grade 10 and 11 in your finance section. So compound interest, simple interest, depreciation, all of those formulas you will have seen before, and then we're going to add our annuities to it as well. All right, having a look over here, making use of logarithms to calculate the value of the time period. All right, you've learned logs, okay, as one of the sections, the first sections we learned this year, all right? And a log is useful, remember, to help us solve an exponential equation where the bases cannot be made equal to each other on either side of your equal sign, okay? So your log is a very handy tool in finance to help us solve that value for n, all right? So that's using our logs to help us solve for the n. We're having a look at problems involving present value and future value annuities. Now, an annuity is a new word that you might be faced with this year in finance. And basically, an annuity is where you are dealing with either you are saving money towards a greater amount, or you're paying money back towards a loan, but you're paying it off in equal monthly or equal installments, whether it be monthly or whatever the time period is. But the point is that it's regular payments that get made towards a greater total sum of money that you are saving. That's your future value annuity. Or whether we're paying off a loan, such as let's call it a car, if we financed a car or something like that, and we're paying money back towards that, your present value annuity. Okay, right. Oopsie. Okay, we're going to quickly show you the challenge question over here, and everybody can take some time to have a look at it and to see if you guys can get the answers correct. Okay. We've got two graphs which are below, and they represent the growth of two investments, one belonging to Tyron and the other belonging to Zanele. Both investments earn interest annually, and it's just annually. We're not compounding it anything other than annually at this point, okay? So the diagram is showing two different types of interest on an investment. Okay. So what you guys are going to do is you're going to take a careful look at that diagram, and here are the questions that you are going to have to answer on it. Okay. What is the initial value of both the investments? So I want you to take a careful look at the diagram, and I want you to see if you can work out what is the starting principal amount of each of those investments. Okay. Once you've had a look at that, I want you to tell me, does Tyron's investments, and if you'll see over here, there's Tyron's investments, does it earn simple or compound interest? Okay, so from the diagram, you should be able to see whether it's earning simple or compound interest. And once we've done that, we want to see if you can work out for us, what would the interest rate be on Tyron's investment? So you need to look at the diagram and see if you can figure out what would his interest rate, I'm going to really emphasize that word rate, be on his investment. Okay, so guys, have a careful look at that. Let's see how well you do with that challenge. Okay. Formulas, financial maths, we know that there's a lot of formulas, guys. A lot of them, as I mentioned, you should already know and be very familiar with. So let's go through them. Let's make sure we know what every one of them stands for. Right, simple interest. Simple interest, this is where we have our principal amounts and we apply interest once, okay, over a certain period of time, and we get an amount. Okay, so our simple interest is our straight line interest, and the formula that we apply is our A is equal to P multiplied by 1 plus I times N, okay? And guys, just to make sure we recognize what each of the values mean. P represents our present value. It's the amount that we have now before we've added any interest or anything onto that, okay? Our A is our final accumulated amount. It's the amount of money that we have after the time period with the accumulated interest. The N represents your time period, okay? How long did this interest get accumulated over? And our I represents our interest rate. Now, please remember, and this is very important, your interest rate is a percentage, okay? So when they give it to you as a percentage, you've always got to remember that percentage means you are putting it over 100. So please don't forget, let's just say, for example, in your sum, they told you that your interest rate is 16%. When we put it into our I in our formula, we have to remember that it is 0.16, okay, because we divided it by 100. So don't forget that you must always remember to do that, okay? Right. Then compound interest. Right, your compound interest, the concept of compound interest. We have an amount, and that amount earns interest over a period of time. That new amount that has earned interest over the period of time is then calculated, interest is calculated on that accumulated amount. So it's a greater amount that interest is calculated on, which gives me a greater amount. Which interest is calculated on? It gives me a greater amount, and so this grows exponentially, all right? So therefore, your compound interest, where your straight line interest is going to grow at a regular constant rate, your compound interest is going to have a much more exponential growth, okay? So your compound interest, the formula, almost very similar in terms of its notation, except the only thing is that we don't have I times N, we raise our bracket to the power of N, okay? The I still represents your interest rate, the A is still your accumulated amount, your P is still the present value, the value that you started with, okay? Just to remind you, if we talk about depreciation, okay, straight line depreciation, that would be your simple interest depreciation. The formula, remember guys, is going to stay exactly as it does with the interest. It's just that instead of a plus, we would have a minus. So for your straight line depreciation, I'm going to have 1 minus I times by N, okay? And for your reducing balance, that's your depreciation on a compound basis, that is going to be A equals P 1 minus I to the N, okay? So remember something like the value of a car. If we buy a car over the period of time as it gets wear and tear, as it grows a little bit older and maybe a little bit out of fashion, so the value of the car depreciates, and so we would apply the formula of your depreciation, okay? Right here, that kind of covers our grade 10 and 11 syllabus. Okay, so everything that we learnt over there is in our first 2 blocks. In grade 12, we introduced you guys to annuities, and as I explained earlier, your annuities is when you are taking you are either saving towards a greater amount or you're paying off a loan, all right, and you're doing it in regular intervals, regular intervals of payments. Okay. So let's talk about the future value annuities. All right, guys, when we're talking about a future value annuity, we are saving money towards a greater capital amount, okay? A typical example I could use for a future value annuity is a retirement annuity, okay? If we're diligent about it, we start at 25 years old and we start putting money away every month, the same amount, month after month, until we, however old, 65, and then we decide, right, we're ready to retire, and that amount that we've been saving is our future value. That future value is what we've now saved towards, okay? However, our present value annuity is where we've taken out a loan, a present value of a loan, okay? Today, I went to the bank and I took out a 10,000 Rand loan. Today, that's the present value of my loan. I now have to pay that money back, okay? And obviously together with interest. So the annuity will be the monthly payment that I'm paying back towards that loan that I've taken out, okay? So the difference between your future value and your present value. The formulas, guys, please make sure you know them, all right? Don't waste time in your exams fiddling around with which ones are which. Know your formulas. Your future value formula. Future value is equal to X. Now that X over there represents the monthly payment that's being made, all right? So X multiplied by the bracket of 1 plus I to the power of N, okay, I being your interest rate, minus 1 over I, all right? That's our future value annuity formula. And our present value annuity formula, X, again, X representing the monthly payment that's being made, all right, multiplied by 1 minus, brackets, 1 plus I, all to the power of, please make sure you know this, negative N. We're raising it to the power of negative N, all over I, okay. Right, a couple of things to please watch out for. Interest rates, okay? If I've said to you, I've got a 16% interest rate compounded monthly, all right? You must remember to take your 16%, let's write it over here, so 0.16, because remember, its percent is always divided by 100. And if it's compounded monthly, we've got to remember to divide that by 12, okay? If it's compounded quarterly, we have to remember to divide our interest rate by 4, all right? Biannually, that's twice a year, so I would divide it by 2, all right? So make sure that you don't forget to divide by your compounding periods. Okay, so that's your interest rate. Something else to watch out for when you are working with annuities, okay, is something called a timeline. Okay, there's an example of a timeline over there. Guys, this is an incredibly handy tip to remember. When you have got a question, and you'll see in a few minutes how when we go through examples how we actually apply this, but a timeline is an excellent way of taking all of this information that they've given you in your question and just helping you to put it in order, okay? Your timeline will always start at T0 and it will work up to whatever the final period you will have. In this case, they've gone up to T5. Sometimes we go up into the hundreds, okay? So that's not, you don't think you're wrong if it goes so high as that. And you've got to remember then that once you've got that, it helps you to just really structure your question really nicely, and it's very, very helpful. Okay, so things like if they say to you, a payment is made at the beginning of every month and up until the final period. So if I've got my first payment, which is made at the beginning of every month, and the same amount is getting paid at the beginning of every month, then we would know that that would be the last time that I would make my payments, okay? If it says that we've made a payment at the very beginning of my T0 and my final payment gets made at the very end of T5, well, that would mean that I would have another X over there, okay? However, you've got to watch out here because N, which represents the number of payments that are being made, if my first payment is made at T0 and my last payment is being made at T5, what actually is my value of N? you've got to watch out here because your n would actually be 6. You would have 6 payments of x if you started at 0 and you ended at 5. However, if you started at 0 and you made your payment at the beginning of every month, well, that in that case would mean that this one wouldn't apply, that one wouldn't apply, and in that case, then your n would be 5. Okay, so you've got to read your question very carefully. When you're reading it, is it a future value annuity? Understand what the question is asking you. Are they saving money or are they paying money off towards a loan? Okay, that's the first thing you obviously want to make sure you understand, because it depends on which formula you're going to be using. Then once you've decided that, make sure you're clear as when the payments are being made. Is it the beginning of every month, or do they start at the end of every month? Okay, is the first payment being made at the end of the first period? In which case that would then eliminate this one. If the first payment was made at the end of the first period, then my first payment would be made there. Okay, and in fact, with present value annuities, that is always going to be the case. When we're paying off a loan, the first payment always gets made at T1. The last payment will always be made at the very end, because obviously once your final payment is made, the loan is paid for and it's finished. Okay. Right, guys, so that's a whole lot of information just on the theory behind all of this, but we're going to take a short break, and when we come back, we're going to get going on a whole lot of examples.
Well said. So you say, Tamlin, you took a loan, a 10,000 Rand loan.
Yeah.
We must share. We'll talk during the break.
We'll talk, okay.
Right, Mansitors, keep your questions coming. We're here to help you. Facebook.com/LearnExtra. We'll see you after the break. Welcome back, Matrix. If you just joined us now, you're a bit late, but you can still catch up. You haven't lost much. Get your notes right now on learn.mindset.co.za. I love also the interaction on the page, Mindsetters. Let's keep it going by helping one another. The challenge question is posted. Send us your answers through to the posted picture on Facebook. Tamlin?
Right, after all of that theory, grade 12, let's get going on some examples. And hopefully what you'll see is that things like using the timeline, okay, how useful it is and how helpful it is, okay. Right, let's take a careful look. Read your questions carefully. This section is very wordy, so you obviously have to just take time to make sure you've understood what they are asking, okay. Right, 3,000 Rand is deposited into a savings account at a bank, and the interest paid is 15% per annum compounded interest. Okay, so per annum, meaning it's compounded once a year, all right? After how many years will the investment be worth 5,250 Rand? The first question I want to ask you, grade 12s, is would this be an example of an annuity, okay? And I'm hoping your answer to that is no, it's not, all right? And the reason why it's not is because there's no regular payment being made every single time, okay? This is just one amount, and we're applying the interest rate to it, okay? So it's not a future value annuity, it's just a normal compound interest, okay? This, what do we have? Okay, so we know that our 3,000 Rand, which is our present value, was deposited. We know that the final amount actually came to 5,250. So we know the A and we know the P, all right? The interest rate is 15% per annum, and don't forget to divide that by 100, okay? Right, so let's put it into our formula. A equals P multiplied by 1 plus I, and they told me it's compounded, so there's my formula to the power of n. Okay, let's plug in. We know that the final amount that this all accumulated to was 5,250 Rand. The initial amount was just 3,000 Rand, and the interest rate is 15%, so it's 0.15. And we don't know how long this was all done over. That's basically the question that we're trying to establish. How long was this compound interest for? So let's see what we need to do. We need to first of all grab out our calculators, because this is obviously one of those sections we need our calculator for. And let's see what we've got. We are going to have to, so let me move this to the side first of all. We're going to have to essentially move everything away from the left-hand side until I'm able to solve for n. Okay, so it's like an equation, all right? And the first thing I'm going to do is, instead of multiplying my 3,000 to my bracket, I'm going to divide it. So I've got 5,250, and I'm going to divide that by 3,000. That's then going to leave me with a 1 plus 0,15, and it's to the power of n. Okay. Right, so let's take our 5,250, and we are dividing it by 3,000 equals. Okay. So I've got 7 over 4, which is equal to, I can add those together, which is going to give me 1,15 to the power of n. And now what we're left with is an equation. We essentially have an exponential equation where the bases on the left-hand side and the right-hand side, they're not the same, okay? So this is where we're going to have to use logs, all right? And I'm going to take my logs, and I'm going to add a log in front of both the left-hand side and the right-hand side. So log 1,15 to the n, okay? Right, so out come our laws of logs, and what we know is that our exponents can be written at the front. So we're going to say log of 7 over 4 is equal to n log 1,15. Okay? To now solve for n, I'm going to say log of 7 over 4, and I'm going to divide that by log of 1,15. And that's going to be equal to your n. Right, so let's do that. All right, we've got our log, and we've got our fraction of 7 over 4. All right. Sorry, guys. Delete that. Right, and sorry, this is now. There we go. Divided by, and we've got another log of 1.15. Close that bracket. Equals, and we're getting 4.00, which if I round it off, I'm going to say is equal to 4. Right, so the number of periods over which we did this compounding, so it actually was over 4 years that because we were compounding it annually, that amount, that 3,000 accumulated to 5,250. Okay, so there was a good example of using logs to help you solve for your n. All right. Okay, let's look at another example. Suppose we have 1,000 rand, which is deposited immediately. Here are keywords, guys. It's deposited immediately into a savings account and continues to make monthly payments. Aha, if it's monthly payments, we definitely know we're talking annuities. At the end of each month, okay, that's important, at the end of each month for a period of 5 months. Interest is 18% per annum compounded monthly. How much money will have accumulated at the end of the 5th month? Okay. Here's a perfect example for me to start introducing your timeline, all right? We know that it's an annuity because it says regular monthly payments are being made. Okay, so we've got our timeline over here. We're going to start at T0 because that's always our starting point on our timeline, all right? And it specifies that we're doing this for 5 months. So it's not a very long, not a very big timeline. We're only going over from 0 to 5 months. So term 4 and term 5. Okay. Right, now let's put in here what it says. Suppose 1,000 rand is deposited immediately. So do you guys agree with me? I'm going to put 1,000 rand right at the starting point because that's exactly what they said. Okay. It continues to make monthly payments at the end of each month for a period of 5 months. Okay. So we're making this monthly payment of 1,000 rand, which got made at the end of the 1st month. It's getting made at the end of the 2nd month, at the end of the 3rd month, and so on. And the last payment would then obviously be made at the end of the 5th month. Okay? So let's see. The interest rate is 18% per annum. So what I'm going to suggest we do, for the whole period that this money is accumulating interest, the interest rate is staying constant at 18%, compounded monthly. So we've got to remember to divide that by 12. Okay? Now that we've done that, we're going to actually put it into our equation. So to calculate our future value, we are going to say x multiplied by 1 plus I to the power of n minus 1 all over I. Okay? X represents the monthly payment that got made. So I've got 1,000 rand multiplied by 1 plus our interest rate, which we've worked out is 0,18 divided by 12, to the power of, now how many months did this go on for? How many deposits of 1,000 rand got made? I've got 1, 2, 3, 4, 5, 6. I started at T0 and I ended at T5, which meant that there were actually 6 deposits of 1,000 rand. So therefore we are raising this to the power of 6 minus 1, and it's all over our interest rate of 0.18 over 12. Okay, let's get our calculator out. And let's put our fraction in. So I'm going to start with 1,000. And guys, I'm literally typing this in really as I see it. So 1 plus my interest rate of 0.18, no, sorry, 0.18 over 12. That's to the power of 6 minus 1, close your brackets, and it's over 0.18 over 12 equals. So 6,229 rand and 55 cents is how much that all accumulates to over that 5-month period. So that's a really good interest rate. Okay. All right. So first of all, can you guys start to see how that timeline just helps you take all those words that have been given to you in a sum, and it starts you to help you just put it into kind of a logical space on your timeline over there. So I hope that that starts to help. But we'll do another one and see if it makes a bit more sense. Right, a very common type of question in exams. We've got an investor who's aged 25, and she wishes to accumulate 10 million rand by her 50th birthday. She will pay equal monthly payments into her accounts, paying 15% per annum compounded monthly, and payments start on her 25th birthday, and they end on her 50th birthday, okay? Find the monthly payments. Okay, so there's a whole lot of stuff happening here. Let's try and see if we can make sense of it on a timeline. Okay, we are going from 25 to 50, all right? So obviously that's a gap of 25 years, all right? And she's making a payment every single month. So the first thing we have to establish is how many months will there be in those 25 years, okay? So we've got 25 years times by 12, which is giving me a total of 300 months. So we're working with 300 payments that she's going to be making into her investment here, okay? Right, so let's start with T0. Obviously, it would go T1, T2. Now, obviously, you're not going to sit there and do 300 little spaces on your number line. So what we can do is give ourselves a bit of a gap there, and we can go right to the end of T300. But what I would suggest is just go one jump back as well. So we've got T2 299, term 300. Okay. Right, this young investor is paying an amount into her investment, and she's doing it on her 25th birthday. So that means that on the day, so that would have to be right there, but we don't know how much she's investing, so we're going to have to call it X. Okay? And she's investing that same amount every single month, until it says her 50th birthday. That's her 50th birthday right there, okay? So the first thing I want you to, well, not the first thing, we've done that already, hey? But the next thing that I want you to now consider is how many deposits of X rands has she made? We started at T0 and we've gone all the way up to T300. Can you guys see that we're working with 301 deposits? Okay. So that's very important. So let's now calculate. We know that the future value that she's working towards is 10 million. Okay? The future value formula is X, that's the monthly deposit, which we don't know, multiplied by 1 plus. Now the interest rate was 15% compounded monthly. So that's going to have to be 0.15 divided by 12, all right? And that was to a power of 301. 301 payments minus 1, and it's all over our 0.15 over 12. Okay, so we've used our timeline to help us make sense of what it was saying in the sum, and from there we've now put our formula together. Okay, now guys, it's a case of solving for X. So calculators out, and let's see what we're going to have to do. First things first. Sorry, let's get rid of the calculator for a second. This line over here means divide. All right? So to get rid of my divided by 0.15 over 12, I'm going to take dividing it on the left-hand side, and I'm going to multiply it on the right-hand side. So 0.15 over 12 is getting multiplied on the right-hand side. So that's my first step. So 10, 1, 2, 3, 6, and I am timesing that by 0.15 over 12. Okay, so I've now got 125,000 Rand. What's the next thing that we need to move away from the left-hand side? So now this has moved away, so I've now got 125,000, which is now equal to x multiplied by all of this. Okay, 15 over 12 to the power of 301 minus 1. Okay, so the best way to do it, guys, is to take out our calculator, and I'm going to move it to the side. My 125,000, I'm going to divide it by that entire bracket over there. Okay, so I'm taking the answer that's in my calculator, so I just press answer, divided by, and now we need to type this in. So I've got bracket and another bracket. 1 plus my fraction of 0.15 over 12, and that is to the power of 300, oh goodness, to the power of 301, and that's minus 1, close that bracket, equals. Okay, right, and that is going to solve for x. So 3,044 Rand and 71 cents is the monthly payment that this woman is going to have to make in order to accumulate that desired amount that she wants on her 50th birthday. Okay, it's a very good interest rate, guys. Yeah, if you can get a bank to give you that kind of interest rate, great. Okay, let's see if we can get another example in quickly before our break. Okay, another annuity, another timeline that we are going to use, all right? How much can be borrowed now if a person agrees to pay a loan by means of quarterly payments? Remember, quarterly payments are made up of periods of 3 months each, okay? Of 7,000 Rand starting in 3 months from now. The payments will continue for 3 years, and the interest rate is 16% per annum compounded quarterly. Right, so we get out our ruler and we draw our timeline. How many periods are going to be working with here? All right, let's think about this. We're talking about 3 years, and we're compounding quarterly. All right, so 3 times 12. Let's first work out how many months in 3 years. 3 times 12, which is 36. And quarterly means we're going to have to divide that 36 by 4 because we're grouping it into groups of 3 months each, getting us to 9 periods. Okay, so on my timeline, it's going to start at T0 and it's going to go all the way up to T9, and just go back 1, let's say T8 as well. It says that she's making deposits of 7,000 Rand starting in 3 months from now. Okay, so the question is, where do we put the first 7,000 Rand? I'll tell you what a lot of people make the mistake of thinking. A lot of people make the mistake of thinking that your first 7,000 Rand gets made at your 3rd period. But you need to think about this. 3 months, remember, if you're dividing a year into quarters, each quarter is made up of 3 months. So please watch out, guys. If you think about it, each one of these little jumps on your number line is actually made up of 3 months, okay? So when it says it's starting in 3 months' time, what they're saying is you're starting at T1. Your first 7,000 Rand is getting made there. That deposit is being made there, all right? And thereafter, we keep making our deposit of 7,000 Rand, and we will then make our final deposit at T9. Okay, so into our future value formula, future value is going to be equal to the monthly payments we know are 7,000 multiplied by our interest. In fact, we know what our interest is, so let's just write that down. Our interest, which is where is it now? 16%, so 0.16, and it says compounded quarterly, which means that's going to have to be divided by 4. Okay? Sorry, repay a loan. Sorry, I'm using the wrong formula. I'm not reading this carefully. If you're repaying a loan, you are paying that's your future value. Sorry, your present value. sorry, present value. Okay, we were playing a loan over here. So our formula, 7,000 multiplied by 1 minus 1 plus 0,16 over 4. And it's 9 periods because we started at T1 and we finished at T9, okay? So we're going to raise it to the power of negative 9. Remember, if you're paying back a loan, that's the formula we need to use, and 0,16 over 4. Okay, so let's clear that and let's type it in. So we've got our 7,000 multiplied by 1 minus brackets 1 plus 0.16 over 4. Close our bracket. That's to the power of negative 9. And close that. All over your 0.16 over 4 equals. Okay, so therefore, what was the value of the loan? If to pay it back, you had to pay 7,000 Rand each time, the value of your loan, 52,047 Rand and 32 cents. Okay, right, guys, so there was an example there of your present value annuity as opposed to future value, where you were paying back that loan. All right, I think it's time for another break already. And then when we come back, we'll have a look at that challenge.
Yes, it is, Tamlin. And here's a comment from Mtaki Mngoma. I love financial maths. Thanks to Mindset. Thanks to you, Mindset. I also help other Mindsetters that are still confused on the page. Otherwise, we'll see you after the break. Welcome back, Mindsetters. If you still have some questions, I am here for you. Send them through on facebook.com/LearnExtra. We'll take them through after the challenge question. I've seen a lot of answers, Tamlin, from the Mindsetters on the challenge question. I hope they're right.
All right, well, let's have a look at those. And then there have been a couple of questions which I'm more than happy to go through and just clarify with you guys. So we'll do that now. Right, the challenge question. So the diagram represents one of your investments being at a simple interest and the other being compound interest, okay? And I think by in virtue of what I've been saying up till now, I think it's easy to figure out that your straight line is obviously your simple interest, where your exponential graph is your compound. So what is the initial, okay, so starting, what is the initial value of both the investments? Okay, so right over there, that's our starting point, and it does say in thousands of Rand. So our initial value for each of the investments was 15,000 Rand, okay? Does Tyron's investment earn simple or compound interest? Well, looking at his growth, we can see that that's straight line. It's a constant annual growth, so therefore we've got simple interest over there, all right? And then a question a little bit more interesting, determine Tyron's interest rate, okay? How do we do that? Okay, we're talking about interest rates and we've got to relate it back to the graph. So hopefully if you're thinking about interest rates, you're thinking about gradients, okay? Because your gradient, remember, is your rate of change, okay? So we need to establish what in fact was the gradient of that pink line representing your simple interest. And this takes us really back to graph theory, actually, where we're finding the gradient of a line. The gradient of a line we calculate by taking the change in y over the change in x. Okay, so what we're looking for is 2 points on this line. So so I've got this point over here, I've got this point over here, and if you actually notice, we've got that point over there, all right? Now, the reason why I can't use B is because I've got the coordinates of 12 and W, so I don't know what W is. It's not going to help me. But I have the coordinates of A, which was 6 and 31. And I've got the coordinates of my initial investment where my X was 0, but my Y was 15, okay? So therefore, we can substitute that in. If I've got y2 minus y1 over x2 minus x1, and let's get that. So we've got 15 minus 31, and it's over 6 minus 0, which is just 6, and that's going to give us 15 minus that over that. Oh, sorry, rips, I've got this the wrong way around. That's 0 minus 6. Okay, so we're landing up with a positive 2.7 as your gradient. Okay, so therefore 2.7% would have been the simple interest. How did everyone do? Did we get anybody who got that?
There are mindsetters that got it right.
Fantastic.
So well done, mindsetters. It shows that you're working and
Fantastic.
concentrating.
Well done, guys. That's really well done. Excellent. Okay, I know, Abraham, we had a couple of questions, so I'm going to go back to a few of them, and let's just see if I can help you out understanding exactly what I was talking about in a couple of the questions. One of them had to do with this question over here. Okay, the learner, the mindsetter has asked, why did I not times, okay, because obviously we've learned, and you guys are right in remembering this, we learned that if I divide my interest rate by 12, we have to multiply the n by 12 as well. Do you remember that, okay? So the mindset is asking, why did I not times that by 12? All right, now the reason I didn't is because of this. When we have that n over there, that n represents the number of periods. If your number of periods is in years, all right, so if that 6 represented 6 years, then I would times it by 12. But this over here, each one of these jumps is already in months. We're talking about months each time I'm jumping, not years. So it's already in months. So I don't need to times it by 12 because by timesing it by 12, you're converting the years to months, which has already been done. Okay, so that's why I didn't times it by 12. I hope you understand that. Okay. All right, that was the only question regarding, the only query on that question here. All right, then we had another person, and not sure why I made it 301, okay? Guys, this is just something you've got to read your question very carefully. Let's go back to the way they worded this, okay? They said that she's going to make a payment. She'll pay equal monthly payments. Sorry, I've actually drawn over this, so let me take that away. She's got equal monthly payments, which are being made, okay, which to start on her 25th birthday and to end on her 50th birthday, all right? So what the first thing we said is what 50 minus 25 gave us 25 years, okay? And I divided that by the number of months that would be. So 25 times 12 got us to 300 months, okay? But just remember, when you're born, the day you're born, you're not 1 year old, okay? You have to take a whole year to get to 1, all right? So therefore, why do I start at T0? Because that's the starting point. To get 1 year down the line, I actually have to still take that journey. I still have to take that jump, okay? So the first payment, which represents the day she turned 25, and the 300th payment, which represented the day she turned 50, okay? Now, if she made the payments of X on her 25th birthday, which is at T0, that means that there's already a jump there. There's already a payment being made by the time I get to T1. So by the time I get to T1, I've already got 2 payments. And so it would go that there's always that 1 extra payment. So by the time we got to T300, there was 301 deposits of X that were made and not just 300. Okay. If the question had been worded that her first deposit was made 1 month after she turned 25, okay? So if it was 1 month after she turned 25, then do you agree I wouldn't put an X above my T0, I would just put it above T1, and that would mean that I would then only have 300 payments. Okay, so there we go. That I hope clarifies why it was 301 and not 300. It's about reading your question, guys. You've really just got to make sure you're clear as to when they are telling you those payments are being made. Okay. All
awesome,
right.
Timlin. I have another question for you.
Yes.
How do you see that it is a loan while the question doesn't tell you that it is a loan? Please help. It's based on question 4. That's from Omega.
All right, let's go to question 4. All right, so how much can be borrowed now? Okay, that's another word for loan. Okay, so anything where you are borrowing money, where you having to pay money back, okay, that's got to be your present value. So even if they said a bond on a house, a payment on a bank loan, anything where money has to get paid back, okay, that's your present value. They might not always use the word loan, okay, like they have over here. They've said, if I borrowed an amount now, okay, that's the present value amount that we've taken out as a loan, and we have to pay that back with interest. So anything to do with the fact that money is getting paid back towards an amount that was borrowed, present value. Anything where money is being saved towards a bigger amount at the end of the whole timeline, that's your future value. Again, love, it's wording. You've just got to make sure that you read it carefully and just take a minute to really read it in your exam and be clear on which one they're asking you for.
Right.
Okay.
Thank
If
you.
we can, we've got a little bit of time. I'd really like to have a look at a sinking fund.
All right. Here's another question.
Yes.
Before. On which situation are we supposed to use the future value formula?
Okay, exactly what I've just said. So your future value is where you are saving money towards a greater amount. So anything where you're saving money towards your retirement, you're saving money towards a holiday, but obviously the annuity part is that irregular equal amounts are getting paid every single time period. That's your future value annuity. All right.
Right.
Okay, let's have a quick look at a sinking fund because that is a very important. I'm going to skip that. Sorry, guys. Right, sinking funds. Very common type of question, so please make sure you understand this because it's very likely that they come up. What is a sinking fund? Okay, if you bought a car today and we drive it around, because a car depreciates in value, by the time you sell that car, you're not going to have enough money to replace it, to replace it with a new one because you're going to sell it for less than what you bought it for. So what we do is we say this, okay? I'm going to start on the day you bought your car. You're going to pay back your loan like normal, but what you're also going to do is you're going to start putting money away as a future value annuity because essentially you're saving money, and that money is getting saved up so that when you sell your car and the money depreciates to a certain value, your sinking fund is going to make up the difference for you to be able to replace it with a new car in, let's say, 5 years' time. So it's money that we put away and we save to make up the difference in value. All right. So let's quickly have a look here. A school purchases a photocopy machine for 150,000 Rand. The machine depreciates at 22% per annum on reducing balance. The school wants to buy a new machine in 5 years' time. The machine will cost much more in the future and its cost escalates at 19% per annum. The old machine will be sold at scrap value after 5 years. Okay, that's at the end of its useful life. A sinking fund is set up immediately in order to save up for the new machine. The proceeds from the sale of the old machine will be used together with the sinking fund, and the interest earned is 14.4%. Right, let's do the whole process here. So find the scrap value of the old machine. The old machine initially cost us 150,000 Rand, and it said that it depreciates, all right? It depreciated at 22% on a reducing balance. That means it's your compound interest. So I've got 1 minus 22%, and this is over 5 years, okay? So we've got our 150,000 multiplied by 1 minus 0.22, and it's to the power of 5 equals. Right, so 49,152. So 49,152 will be the value of the old machine when it's come to the end of its useful life, okay? Find the cost of the new machine in 5 years' time. Well, if the current machine costs 150,000 Rand, new machines are, the price of a new machine is escalating at 19%. That's what we were told. So that's going to have to be a compound interest. It's compounding at 19% over that period of 5 years that we saving on our sinking fund. So 150,000 multiplied by 1 plus, okay, and now we've got 19%, and it's to the power of 5, and that's giving us 357, 95304, 953,04. So that's how much a new machine will cost us in 5 years' time. The sinking fund needs to make up the difference between the two. So your sinking fund is the total amount of the investment that we need to replace the machine with, minus the amount of money that we're going to get for the old machine when we sell it off to get its scrap value. Okay? So the sinking fund is therefore, the value of our sinking fund is going to have to be 357,953.04 minus the 49,152. Okay, so we're going to take this answer and we're going to subtract 49,152, and that's giving us 308,801. 308,801. 801.05. That's your sinking fund. That's how much money we have to accumulate. Now, what the last question is asking is, find the monthly payments made into the sinking fund. Okay, so therefore, the second you have to now work with the sinking fund, grade 12s, you have to treat it as a future value annuity, because we're putting money away every single month to make up the difference of 308,801 Rand. Okay, so 308,801 Rand and 5 cents is the value of your sinking fund. How much money we need to put away every month? Well, that's what we're trying to figure out. My interest rate, they told me, was 14.4%. So it's going to be 0.144. And it's compounded monthly. And this was for a period of 5 years. And 5 times 12 is going to be 60. But in fact, let's just be careful over here, because when did we make our payments? Let's just read this carefully. The first payment gets made, the first payment will be made immediately. So the first payment is being made at T0, and the last payment will be made at the end of the 5-year period. So although there's 12 months in the total time period, there's going to be 61 payments that are going to be made. I hope you guys understand that. So it's going to be to the power of 61 minus 1 all over 0.144 over 12. And let me quickly work that out for you on the calculator. So we've got our fraction of, okay, I don't know if I'm going to have time to do that. In fact, I'm going to have to let you guys work that out yourselves. It'll be, the answers I think are on the website. If not, we can put that, I'm sure we can do that for you. But guys, so you know your sinking fund is your future value annuity. Another question, please go on our website and have a look at, is your balance on a loan. All right, that's also a very common question, and you must know how to do that. So please go onto the website and go have a look at that. Thank you so much, guys. I really hope that you're understanding all of that and that you've learned lots. And really, once again, just go and practice it, and I'm sure you will master it.
Thank you so much, Tamlin. And thanks to you, Mindsetters, for tuning in. Really appreciate you guys, and make sure that you have your notes and you also work out the questions that we have. Your notes can be found for free at land.mindset.co.za. But from us and Tamlin and the rest of the team, we just want to leave you. Say good evening and peace.